Okay, so here we have a sushi roulette in the Japanese game show Sushi Roulette. I wonder if it's a real show. Well, it says the contestant spins a large wheel that's divided into 12 sections. 9 of the sections have a sushi roll and 3 have a wasabi bomb. When the wheel stops, the contestant must eat whatever food is on that section. To win the game, the contestant must eat 1 wasabi bomb. Find the probability that it takes 3 or fewer spins for the contestant to get a wasabi bomb. Show your method clearly. Okay, so essentially you want to find the probability that it will take 3 or fewer spins, or the probability that y is less than or equal to 3. So this is an example of a geometric probability distribution, because you're essentially looking at a situation where as soon as you get 1 success, the sequence stops. In binomial distributions, you have it's like you shoot, like it's like if you were to spin this 10 times and count how many times you would have landed on the wasabi bomb if you spun it 10 times. Here you're just spinning until you land on a wasabi bomb. But now we want to be a little more specific. What's the probability that it'll take you 3 turns or less to get on a wasabi bomb? So that's why I'm using y, because y is usually the common notation for geometric random variables, and then x is for binomial random variables. So the probability that y is less than or equal to 3 is going to be equal to the probability that y equals 1 plus the probability that y equals 2 plus the probability that y equals 3. And that's simply because these 3 situations will satisfy y being less than or equal to 3, because 1 is less than or equal to 3, 2 is less than or equal to 3, and 3 is less than or equal to 3. So the probability that y equals 1 is basically you getting on a wasabi bomb on your first spin. So you get a wasabi bomb on your first spin, since you have 3 out of the 12 sections that have a wasabi bomb, that means you have a 3 out of 12 chance, or a 25% chance. Again, 9 have a sushi roll and 3 have a wasabi bomb. So 3 out of 12 in general is your chance of landing on a wasabi bomb, which is 0.25. So that's the probability that y equals 1. The probability that y equals 2 means you're going to land on a wasabi bomb on your second spin. That means on your first spin, you're not going to land on a wasabi bomb. So it means on your first spin, you're going to land on any of the other 9 sections. Since there's 9, 9 out of 12, that's where the other 0.75 comes. So it's going to be 0.75 times you landing on a wasabi bomb, because that means the first time you don't land, but on the second time or second spin you land. So 0.75 times 0.25. That'll be the probability that y equals 2, plus, I'm going to go to the next line, plus the probability that y equals 3 means you don't land on a wasabi bomb your first 2 spins, which is, and then going to be 0.75 times 0.75, because you have a 75% chance of not landing on a wasabi bomb each spin. But on the third spin, you're going to have to land on a wasabi bomb, which is going to be times 0.25. So this in total will give you your overall probability of. And you can use your calculator. So let me go ahead and punch this in my calculator. Get a rough approximation. And you'll be about 0.578. Now, I went through it this way because I want to explain it to you, step by step. But, this actually can be done in your calculator, with simple function. So we can use the geometric distribution function, or we go to distribution in your calculator, and then go down. So it's on bars usually, this old school calculator, and go to geometric cedia. PDF would be like a single event. It'd be like the probability that y equals 3. CDF is the probability that y is less than or equal to some number. And the notation is going to be, let's put this in my calculator. Met CDF. And it's basically N, not N, it's basically PK. It's very similar to binomial CDF, but instead of the N, it'll just be the P and the K. So it'll be P, comma K. So your probability of success is 0.25, and then followed by what you're looking for in terms of what number do you want your success to be on. So K equals 3. Now in this old school, you just enter like this. You just enter the number straight up. So it'll be 0.25 comma 3. If you have like the more recent or updated versions, it'll probably have exactly like number of trials, probability. But in either case, this will just do the calculation for you. And there you go. So make sure you become very familiar with this. Like you should be practicing with your calculator more than your cell phone, because it's really going to save you a lot of time on your AP test.